annoying to hear about past cadets. My next set of cadets are going to hear about you guys. And I told the previous set, yeah, your next set of cadets are going to be irritated hearing your names all the time. All right, a couple formalizations, and then hopefully we'll have some time to go to boards. So when a set is the union of disjoint sets, formalization. So we're a little wishy-washy the way we're doing it right now. So let's suppose I could take a set S and then chop it up into pieces, and such that the union of all these guys gives you that original set. It's not beta. B. And all of these guys are, if I is not equal to j, they don't have any overlap. So let me give you an example of a partition. I could take the evens and the integers and stick them in one box, take the odds, stick them in another box. That's a partition of the integers. I just cut them up into two boxes. So these guys are called the blocks of the partition. Are you guys using that in graph theory, this kind of language? You haven't talked about partitions? It's coming. I just want you to be able to recognize it, like, oh, this is what we did in foundations. So I thought I should use the adult language for how people talk about sum principles and product principles in terms of partitions. Yeah. Oh yes, you would. Yes, that's another fun class. Carl Clark taught you, right? Yeah. Should I tell him that you thought the class was wonderful? What? Yep, at the very beginning, you'll do some counting and you're doing real probability. And yeah, it's a wonderful class. But it probably felt like a shock to the system. Like, what are we doing here? Okay, next thing is that sum and product principles can be split up into this. If you have go.
Then was that what we just wrote the definition of a partition?
Yes, that's the definition of a partition. The sum principle is this. Just add up the size of. Let's see how much you guys remember. What does those symbols mean around the set? Cardinality. So it's the number of elements in the set. The absolute value of the set. I was waiting for that. Say it again. They're disjoint sets. Yeah. That's the definition of partition. They have to be disjoint. So the product principle says that if we have a partition of a set S into M blocks of size n, then the cardinality is going to be m times n. Right, we have time to get started. So I'm giving you some like softball questions with ice cream and sandwiches and counting things. Like these are prompts that they actually give students in elementary school that are in the gifted and talented program. I know that because I actually see those problems come from the teacher. But they'll just count and say, okay, what possible combinations of these things could I have? But really, we're talking about counting functions. That's what's amazing. You're really talking about functions, the way we've defined them, and counting them up. So what you're gonna do is actually these examples that are really easy to see in your head, work them out, and then go from there to transform it to a generalization to functions. That's where we're going with this.
Product principle only works, that's assuming all the participants